Good morning, students. Welcome to our online review on mathematics, session number 5. Our topic for today is about radicals. I'm your lecturer, Miss Annalisa Villamor. All right. Our objectives for this session, the learner should be able to, number 1, simplify radical expressions. Number 2, add and subtract. 3, multiply and divide. Number 4, rationalize the denominator. And number 5, simplifying complex radical expressions. Parts of a radical. The radical symbol is same as the square root sign. And the number inside the radical symbol is what we call the radicand. The number outside of the radical symbol is what we call the index. And the number before the radical symbol or the radical itself is the numerical coefficient of the radical. Let's start with simplifying radical expressions. But before that, here's the perfect squares. Number 1, the square root of 1 is equal to 1. Square root of 4 is equal to 2. Square root of 9 is equal to 3. Square root of 16 is equal to 4. Square root of 25 is equal to 5. Square root of 36 is equal to 6. Square root of 49 is equal to 7. Square root of 64 is equal to 8. Square root of 81 is equal to 9. Square root of 100 is equal to 10. Square root of 121 is equal to 11. Square root of 144 is equal to 12. Square root of 169 is equal to 13. Square root of 196 is equal to 14. And the square root of 225 is equal to 15. Okay, a radical expression is said to be in its simplest form if there are no perfect square factors other than 1 in the radicand. Example number 1. The square root of 25x is equal to the square root of 25 times the square root of x. Square root of 25 is a perfect square, so it is equal to 5. And the square root of x is not to be simplified. It is obviously just cut with the square root of x. So our final answer is 5 to the square root of x. Example number 2. The square root of 64 over 36 x squared. This time, since the exponent of x is to the second power, we can cancel or eliminate the radical symbol and the exponent of the x. Okay, let's start with the square root of 64. It is a perfect square. It is equal to 8. Over the square root of 36. Again, it is a perfect square. It is equal to 6. Then we eliminate the radical symbol and the exponent, so we have x. But look, 8 over 6 can be simplified. So it is divisible by 2. So 8 divided by 2, it is equal to 4. And 6 divided by 2 is equal to 3. Therefore, our final answer is 4/3 x. Example number 3. We have square root of 15 over 49. Square root of 15 is not a perfect square, but the square root of 49 is equal to 7. Therefore, our answer is square root of 15 over 7. Example number 4. The square root of 98 over 27. Both two numbers are not perfect squares, so we are going to think of two numbers that one of those number is a perfect square. So for 98, we have 49 times 2, and for 27, we have 9 times 3. Okay, let's start with the numerator. Square root of 49 times 2 is equal to 7 to the square root of 2. Well, the denominator, we have the square root of 9 times 3 is equal to 3 to the square root of 3. So our final answer is 7 over 3 to the square root of 2/3. Let's proceed to addition and subtraction of radical expression. Example number 1. Negative 20 plus square root of 45. Here, both 20 and 45 is not a perfect square, so same process. For 20, we have 4 times 5, and for 45, we have 9 times 5. Okay, let's proceed. So it is the negative square root of 4 times 5 is equal to negative 2 to the square root of 5, plus the square root of 9 times 5, we have 3 to the square root of 5. So since we have the same square root or the radical, same of square root of 5, we can add negative 2 plus 3. So negative 2 plus 3, we have positive 1. You don't need to write 1. It's automatically 1. It's the same, the imaginary 1 numerical coefficient of the radical number. So therefore, our final answer is square root of 5. Example number 2. The square root of 50 plus square root of 27 minus square root of 8. So the same process, students. So let's start with the square root of 50 is equal to square root of 25 times 2 plus the square root of 27 is the same as square root of 9 times 3. And the negative or minus square root of 8 is the same as minus square root of 4 times 2. Okay. For square root 25 times 2, we have 5 to the square root of 2 plus for square roots 9 times 3, we have 3 to the square root of 3. For our square root of 4 times 2, we have minus 2 to the square root of 2. In this case, we have 2 radical, which is the same. So we can add 5 minus 2. So here, the difference is positive 3, then copy the radical square root of 2. Then copy the remaining, which is 3 to the square root of 3. Therefore, our final answer for the given situation is we have 3 to the square root of 2 plus 3 to the square root of 3. Example number 3. We have 5 to the square root of 12 plus square root of 32 minus square root of 72. Okay, it's the same. Okay, copy the numerical coefficient of 5. Then for the square root of 12, we have 4 times 3 plus the square root of 32, we have 16 times 2. And for square root of 72, we have 36 times 2. So first, copy the numerical coefficient 5. Then bring out the square root of 4, so it is equal to 2 times the square root of 3 plus square root of 16 times 2, we have 4 to the square root of 2. Then for square root of 36 times 2, we have 6 to the square root of 2. Then we are going to multiply first. 5 times 2, we have 10 to the square root of 3 plus 4 to the square root of 2 minus 6 to the square root of 2. In this case, we can add the two same radical, which is 4 to the square root of 2 minus 6 to the square root of 2. So 4 minus 6, we have negative 2 to the square root of 2. And we just copy the 10 to the square root of 3. Our final answer for this example is 10 to the square root of 3 minus 2 to the square root of 2. Okay, example number 4. We have 2 to the square root of 18 minus square root of 98 plus 3 to the square root of 50. Okay, again, same process. So copy the numerical coefficient of 2. Then for square root of 18, we have 9 times 2. For square root of 98, we have 49 times 2. And for the square root of 50, we have 25 times 2. Okay, let's proceed. So 2 times 3, we have 6 to the square root of 2. And then minus the square root of 49 times 2, we have 7 to the square root of 2. Plus 3 to the square root of 25 times 2, we have 5. So 3 times 5 is equal to 15 to the square root of 2. So since 3 radicals have the same square root of 2, we can add or subtract 3 numerical coefficient. So 6 minus 7, we have negative 1. Negative 1 plus 15, we have positive 14 square root of 2. So let's proceed to multiplication and division of radical expression. Example number 1, we have square root of 50 times square root of 14. We can do other process. We have the long method and the short method. In the short method, you can multiply 50 times 14, so it is equal to 700. Then think for two numbers that has a number that will be a perfect square. So that is 100 times 7. So square root of 100 is equal to 10, 10 to the square root of 7. So while the long method, we have here the square root of 50 is equal to 25 times 2, and the square root of 14 is square root. 14. So same. So the square root of 25 times 2, it is equal to 5 to the square root of 2. Then you can multiply 2 times 14 is equal to 28. Then by this time, 28 has a 2 numbers or factor that when you multiply one number, it's a perfect square, which is the 4 times 7. Okay, bring up the 4, bring out the square root of 4, it is equal to 2. So 5 times 2 is equal to 10 to the square root of 7. So it is the same. So either of the two, you can follow the steps or the process on how to simplify or multiply the given radical. Example number 2. We have 4 to the square root of 6x times square root of 10x. Okay, here we're going to multiply the numerical coefficient. 4 times 1, we have 4. Then the radicand to radicand, we're going to multiply 6x times 10x. So it is equal to 60x squared. So here, think for two numbers again for 60. Okay, we have 4 times 15 x squared. Then 4 is a perfect square. Then bring it out. So 4 times 2, we have 8. Then copy the radical square root of 15. And then the square root of x squared cancel the radical symbol and the exponent. Then we have x. So 4 times 2, we have 8 times x. We have 8x to the square root of 15. Okay. Let's move on for example number 3. So square root of 18 divided by square root of 25. So the square root of 25 is a perfect square. The square root of 18 is not. So we have two numbers here, 9 times 2. Then we bring it out. The square root of 9 is equal to 3. The square root of 2 over 5. So example number 4, we have square root of 2 over 5 or square root of 2 divided by 5. So in this case, it is a simple rationalizing denominator. Okay, in this case, we are going to multiply by square root of 5 over square root of 5. If you can see, we used the denominator square root of 5 in order to rationalize it, to make it a perfect square. So let's proceed. Square root of 2 times square root of 5, we have square root of 10. Then square root of 5 times square root of 5, we have square root of 25. So that is a perfect square. And it is equal to 5. So our final answer is square root of 10 over 5. Example number 5 is the same. We are going to rationalize radical expression. The given example is square root of 24 over 5 to the square root of 3. In this case, the radical that we are going to use is the square root of 3. Okay, let's proceed. Square root of 24 times square root of 3, we have the product of square root of 74. Then 5 times 1, we have 5. Square root of 3 times square root of 3, we have 9. Okay, let's proceed. 72 has two numbers that you can multiply. So 36 times 2 is equal to 72. 36 is a perfect square. So 36 times 2 or 6 to the square root of 2. And then the denominator will become now 5 times 3, we have 15. Okay, so our final answer is 6 to the square root of 2 over 15. Okay, let's proceed to complex radical expression. It's a long method here. We have the example number 1. The equation is square root of 2x plus 3 plus the square root of 2x plus 4 is equal to 5. In this case, we are going to find the value of x. And which value of x is the correct one in order for the equation to make it equal to 5. Okay. For this equation, first we are going to square both sides, the left and the right, in order to remove the radical symbol of the left side. So we have here, the remaining is 2x plus 3. This plus, it is plus, square root of 2x plus 4 is equal to 25. Because 5 times 5 is equal to 25. All right. The 2x plus 3, we are going to move it to the other side. So since it is positive, it will become negative. So it is 25 minus 2x minus 3. Therefore, we are going to remove again the remaining radical symbol. So we squared both sides. So we have here, the remaining is 2x plus 4 is equal to negative 2x plus 22 times negative 2x plus 22. All right. So since we have a binomial in our left side, we are going to equate the equation into 0. So for that to make it 0, we are going to transpose or move to the other side, the 2x plus 4. So from positive, it will become negative. So we have here 0 is equal to 4x squared minus 88x minus 2x plus 484 minus 4. So our equation now is 0 is equal to 4x squared minus 90x, 90y, negative 88 plus negative minus 2 is equal to negative 19. Then y 480 because positive 484 minus 4 become 480. So in our quadratic equation, y is equal to ax squared plus bx plus c. In this equation, the value of a is equal to 4, and the value of b is equal to negative 90, and the value of c is equal to 480. All right, let's move to the finding the value of x, and we are going to use the quadratic formula. The quadratic formula is x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. From the equation that we have, a is 4, b is negative 90, and c is 480. We substitute all the values in the given quadratic formula. So it is now x is equal to negative times negative 90. It is equal to positive 90 plus or minus the square root of negative 90 squared. It is equal to 8,100 minus 4 times 4. We have 16 times 480 over 2 times 4. We have 8. Okay. Proceed. 90 plus or minus the square root of 8,100 minus 16 times 480 is equal to 7,680 over 8. So the difference between 8,100 minus 7,680 is equal to 420. And the square root of 420 is equal to 20.49. Therefore, the value of x here is 90 plus or minus 20.49 over 8. So in this equivalent value of x, we can find the two value of x when we use the addition and subtraction. Okay, let's start for our checking. When we use the subtraction for the first value of x, we have 90 minus 20.49 over 8 is equal to 69.51 over 8. So therefore, it is equal to 8.69. So we are going to substitute the value of the first value of x to our equation, to our original equation. So the square root of 2 times 8.69 plus 3 plus square root of 2 times 8.69 plus 4, it is equal to square root of 17.38, the product of 2 times 8.69, plus 3 plus square root of 17.38 plus 4. Then we are going to check if it is equal to 5. Okay. The sum of 17.38 plus 3 is equal to 20.38. And the sum of 17.38 plus 4 is equal to 21.38. And the square root of 21.38 is equal to 4.62. When we add these two numbers, 20.38 plus 4.62, it is equal to 25. And we all know that square root of 25 is a perfect square. It is equal to 5. Therefore, the value of x, which is 8.69, is the correct value for our equation. That the equation is absolutely equal to 5. So let us see the second value of x, when we use the addition. It is equal to 13.81. When we substitute the value 13.81, look at the solution. So we do the same process. We multiply, we add, we find the value of the square root. Then we have here the square root of 36.24. When we get the rounded off into a whole number, it is equal to square root of 36. And the square root of 36 obviously is equal to 6. Therefore, 6 or 6.02 will not equal to 5. Therefore, the second value of x is not the appropriate value for our equation. Okay? That's all for today, students. I hope that you learned how to simplify radical equations. You learned how to add, subtract, multiply, and divide the said radical expressions. So thank you for watching. Thank you for listening. Please prepare for a short assessment.